Hello, Mario. In this video, I'm going to talk about a triangle. Triangles come in many shapes and sizes and forms. But in general, a triangle is a polygon with 3 sides and 3 angles. Let's have a look at what we call the scalene triangle, where all sides have a different length and all angles have a different size. I've used a fairly simple naming convention for my triangle here, where typically the angles are labelled with a capital letter, A, B, C in this case, and the side opposite each angle with a lowercase letter, little a, little b, little c in this case. You'll see that I've indicated that each side has a different length by a single magenta tick, double magenta tick, and a triple magenta tick for the sides C, A and B. So angle B, 3 ticks, angle A, 2 ticks, angle C, 1 tick. Now I've also here labelled the base and the height. The height is always at right angles to the base, or perpendicular to the base. So here we've got side B as the base, and then I've got a pecked yellow line at right angles to the base indicating the height. For a scalene triangle, or any triangle for that matter, the biggest side is always opposite the biggest angle, and the 3 angles of a triangle add to 180 degrees. So in the scalene triangle, A plus B plus C would equal 180 degrees. Now this brings us to the next triangle, which is an isosceles triangle. 2 sides, 2 angles the same. I've indicated here sides A and C with a single tick, indicating that they are the same length. Angles A and C have a single half circle there, indicating they are the same size, and angle B, 2 half circles, indicating that's a different size. And again, the base is side B, and the height, the pecked yellow line at right angles to the base B. I've used the same naming convention here, angles A, B, C, and the sides opposite, little a, little b, little c. And that brings us now to the equilateral triangle. 3 sides, 3 angles the same. As all the angles of a triangle add to 180, dividing 180 by 3, we get 60. So all of the angles of an equilateral triangle are 60 degrees. And all the sides are the same. And again, the base perpendicular, or the height, sorry, perpendicular to the base, as shown here. So all the angles have one arc, circular arc, indicating they're all the same size in red, and all of the sides have one single magenta tick, indicating that they are the same length. And there, that brings us to the right angle triangle, which is a very special triangle in mathematics, the right angle triangle. Again, we use the same naming convention, but typically we try to make the longest side opposite angle C, and side C opposite angle C. So as I've shown here, I've labelled the triangle ABC for the angles. Angle at C is the 90 degrees, the right angle, and then angles at A and B are shown there. Now, one angle is a right angle in a right angle triangle, and the side opposite the right angle is called the hypotenuse. This is a special case, and as I said, the side opposite the right angle is called the hypotenuse. An isosceles right angle triangle is possible, and I've shown one, the second one there down the line. I've shown that with a 90-degree angle. The two sides A and B are the same length, and as it turns out that the angles at A and B would be 45 degrees each. 90 plus 45 equals 180 degrees. So that's an isosceles right angle triangle. The hypotenuse is always the longest side of a right angle triangle, and the right angle is always the biggest angle. The sum of the smallest angles of a right angle triangle is 90 degrees. So in our isosceles right angle triangle, we have 45 degrees plus 45 is 90. All various forms of in combination are possible. We could have a 30-60, which is typically one of the set squares we use in drawing, a 30-60 set square, 30 degrees, 60 degrees, and the right angle, 90 degrees. Now, I have been indicating in these triangles where the base is and the height, but as we've got a right angle, obviously the base is a side and the height is a side in these ones here. Although it is possible in the isosceles triangle there to have a height from at right angles to the base. If AB was the base, or side C was the base, it would be possible to have a height from the side C through to angle C. And I've just pointed out here that it is possible sometimes to have the height of the triangle outside of the triangle itself, in this sort of special case here where triangle ABC, we can see that we have to extend the side AC in order to indicate where the height is, and it's just the height would go from AC extended through to B, like that. So that's a special case. So there you are, some things about a triangle.